Hey guys, let's have a look at rod cutting problem. Given the length and prices of n different rod cuts and a rod of length L, find the maximum price that can be achieved by cutting the rod into different rod cuts. For example, if we are given prices and lengths of different sizes of the rod cuts and the length of rod is 5, then the maximum price that we can achieve is 300, and that is by cutting the rod into 5 pieces of length 1. Okay, now let's see how we are going to approach this problem. This problem is similar to coin change problem. Basically, if we are given length 5, then we can have following cuts. Okay, so basically we can have all these cuts, and what we need to do is we need to find the values for all these cuts and take the maximum of them, right? Now we are going to handle this problem in the similar way as we did in the coin change. The only thing that changes is rather than returning a count, we are going to deal with the values. So what we do is we say that we take 5 and subtract 4 from it, and we take the value at that point of time and say in the recursive call that find a value for remaining length, right? So we will be getting 60. Okay, so that becomes 260. This is one sub problem, and the second sub problem is that we say that we are not going to use this particular cut. In that, what we say is take 5 and try to find cuts that we can get from 3 and below, right? So that is the basic idea. Now let's see how we are going to implement it. Here I have already set up my function. It is RCP and it takes 4 parameters. Let's implement this. Here m is basically the size of the array and n is actually our length of the rod. Okay, here we are going to return the maximum price that we can get. Then we have prices, then lengths, that is each cut length and corresponding price for that, and then here we are going to have number of elements or number of lengths that we are given in the array, and then we are going to have rod length. Okay, so what we want to do is basically we want to subdivide the problem and we want the maximum of it. Okay, so we are going to return okay. What this means is that we are passing n over here. We want to say that we want to try this element again. For example, if we had 5 and we were at 2, then we can say that 5 and take 2 out of it, we are remaining with 3, and then 3 can be made with the 2 and 1, right? So that is what we are doing over here, right? We subtracted the current length and we passed the same element again in order to check. Okay, and in the below level, all we said is that we take the length, rod length, and we want to try with the lower denominations. Okay, and one more thing we want to do over here is that as we have taken the length, we want to add the value, the price of the current element. Okay, so this is for the subdivision of the problem. Now just imagine if that if our RL remaining is actually less than the length that we have in the current index, right? For example, we subtracted 4 from 5, then we have 1 in the next call, and of course 4 is actually greater than 1, right? So if greater than RL, then we don't want to make this particular call. All we want to do is we want to reduce the number of elements in the array. And for our boundary conditions, our boundary condition can be either we have exhausted n. So if we have exhausted n, or our RL equals 0, right? We cannot go below RL because as you can see in this condition, we are only subtracting if and only if the length is actually less than RL, right? So it will be either 0 or it will be greater than the 0, right? So in this condition we are going to return 0, and that is all. I mean, that is all we need to do in order to implement the solution. Let's see if it works fine. So cool, our solution is working fine, right? As we saw in our PPT. Now let's do one more thing over here. Let's convert our function into a dynamic programming solution. We are going to require two-dimensional array because at any point of time we are actually looking at two indices where RL is one index and n-1 is one index. Here we are going to do this. We are going to preserve the value that we have calculated. Okay, here we want n and we want RL over here. And we are going to return this. And one more thing we want to do over here is we want to put an else over here, so that if the above function call is made, then lower function is not called. So our previously calculated values have been preserved in our auxiliary array. Now we want to use it. As simple as that. We are going to initialize our auxiliary array with -1. So this is going to be our base condition, right? If particular value has been calculated, then that particular index will not be -1. Okay. Now one more thing we want to do is we want to pass our auxiliary array to our recursive calls. Okay. This is pretty much it for the recursive dynamic programming solution. Let's see if it is going to work fine. In order to test it, let me we need an auxiliary array, right? So this is our auxiliary array. And let's pass this and let's test it if it works fine. Cool. So our recursive dynamic programming solution is working fine. Okay, so now let's see how we are going to implement an iterative solution for this problem. Okay. So before we actually implement our function, let's have a look at the process that we are going to follow. Here for 0th index we have put all the values as 0, because for 0 weight there won't be anything. Basically you cannot have a value or price for any of the cuts. Okay, we start at 1. Okay, what we do is we subtract this length with the length that we have picked. From our lengths we get a number, right? 1 minus 1 is 0. What we do is we take the value for that cut and add it to the index in the same level, right? Okay, and then we compare it with the value that we previously calculated, right? For that we just go one level up and take the value from the previous index, right? This is exactly similar to this condition. If you think about it, here we are going to have 6. As you can see over here, we say that n remains the same, right? In this particular situation, when we took the value and added to a value in the same level and we subtracted the rod length, basically we subtracted the length of the cut from the rod length, right? That is what we did. If we had a rod with the length 1, then we subtract 1 from 1 and we get 0 index, and we add the value of the rod of the cut and we add it to the index where we have reached. If this particular value is better than previously calculated values, that is at n minus 1, which is one level up, and we say our length is exactly the same, right? So that is what we did over here, and same thing we are going to do for all of them. For 2 minus 1 is 1. We have 6 over here. 6 plus 6 is 12, which is better than previously calculated value, so we take 12. Similarly for 3 minus 1 is 2. At 2 we have 12. 12 plus 6 is 18. 18 is better than 0, and so on and so forth, right? It is going to be pretty much for all of them, right? And here 1 minus 2 is negative, so we take a value from previously calculated value. 2 minus 2 is 0. We come over here, at 0 we have 0. 10 plus 0 is 10, and 12 is better than this particular sum, so we take 12. 3 minus 2 is 1. 1 is 12. 12 plus 10, sorry, 3 minus 2 is 1. 1 is 6. 10 plus 6 is 16, which is not better than previously calculated value, right? Basically this thing will go for all of them, so you can do the pretty much same calculation and you are going to end up with this result, right? Okay, so now let's implement this very quickly. Okay, we'll change the name of our function because it is taking same parameters as our previous recursive dynamic programming solution. Here we are going to require 2 for loops. Okay, first we'll traverse through the weights. Okay, so int I is equal to 1, then I is going to be less than equal to n, and we are going to increment it. Similarly, we'll have another variable, another loop, which will start at 1, and this will be traversing the length. And inside this, we are going to do pretty much the same thing that we did for our recursive dynamic programming solution. The only thing that changes is our indices. Okay, this will be I minus 1 and this will be j. Here it will be I and j. And we are going to take value from I minus 1 and j. Okay, this is the case when actually the length that we have picked for the rod minus the rod cut, right? If rod cut is actually greater than the length that we have picked, then we are going to take a value from the above, right? So that this is this is the same thing here as well. We are going to do pretty much the same thing. We are going to take p of I minus 1 and this will be I and this will be j minus length of I minus 1. Okay, and similarly for this one, args of I minus 1 and this is going to be j. Okay, so this is pretty much it. I mean, that is all we needed to do actually, right? And after the entire loops, all the loops have ended, we'll have result at and that's it. I mean, that's our iterative solution. Now let's see if it works fine. Okay, so something is wrong over here. Here. So let's test again. We have to initialize our arrays with 0. So there we have it. Basically, so that these are the 3 ways for implementing the rod cutting problem, and that's it for this video actually. And if you want the code, I'll be sharing a GitHub link in the description box, and yeah, thanks for watching.